NASA has finally revealed the 4 astronauts chosen for Artemis III. But the real story isn't who they are. The real story is why NASA believes Artemis III could become one of the most complex moon missions ever attempted. Because for the first time in over 50 years, astronauts won't just travel to the moon. They'll attempt something NASA has never done before. For decades, the Apollo missions landed near the moon's equator. The terrain was relatively flat, the lighting conditions were predictable, and mission planners carefully selected locations that minimized risk. Artemis III is different. NASA wants to land near the lunar South Pole, but the real challenge isn't just where they are landing. A region unlike anything humans have ever explored. From orbit, the area appears beautiful. Towering mountains, deep craters, long shadows stretching across the surface. But beneath that beauty lies a problem. The lunar South Pole presents some of the most challenging conditions ever targeted for a human landing mission. Some craters there have remained in darkness for billions of years. Sunlight has never reached their floors. Some permanently shadowed craters near the South Pole rank among the coldest measured locations in the solar system. And this is where things become even more important for NASA. Colder than Pluto. Colder than many objects drifting through deep space. Inside these frozen pits, scientists believe vast amounts of water ice may be hiding. And that ice is one of the main reasons Artemis III is going there, because water means survival. Water can be turned into oxygen. Water can be turned into drinking supplies. Water can be split into hydrogen and oxygen, key ingredients for future rocket propellants. If humanity ever hopes to build a permanent presence on the moon, it must learn how to use these frozen resources. But accessing these resources is far more difficult than it sounds. But reaching them is another story entirely. The terrain near the South Pole is brutal. Massive boulders scatter the landscape. Steep slopes cut through the region. And the shadows create a dangerous illusion. Objects can disappear into darkness without warning. A crater that looks shallow from a distance may be hundreds of meters deep. A safe landing zone may suddenly reveal hidden hazards as the spacecraft descends. Unlike Apollo, Artemis astronauts will not be landing in a familiar environment. They will be entering a place that remains largely unknown. And even if they survive the landing, another problem begins immediately. And then there is the dust. Moon dust sounds harmless. It isn't. The lunar surface is covered with razor-sharp particles created by billions of years of meteorite impacts. There is no wind on the moon, no rain, nothing to smooth the edges. The result is a powder so abrasive that Apollo astronauts compared it to grinding paste. It clung to spacesuits, damaged equipment, worked its way into seals and mechanical systems. And Artemis astronauts may face even more of it as larger spacecraft disturb the surface during landing. But perhaps the greatest challenge isn't on the moon at all, because the risk starts long before they even reach lunar orbit. It's getting there. The success of Artemis III depends on a machine unlike anything ever used for a lunar landing. SpaceX's Starship, the largest and most powerful space launch system ever developed. To make the mission work, Starship must perform a series of operations that have never been completed in a real lunar mission. Before Starship can even travel to the moon, it may need to be refueled in Earth orbit. That means multiple launches, multiple spacecraft, and a series of fuel transfers never demonstrated at this scale for a crewed lunar mission. If the system works, it could transform the future of deep space exploration. If it doesn't, Artemis III cannot proceed as planned. Massive launches, orbital refueling, and history shows exactly how quickly a mission like this can change complex docking maneuvers, then a journey to the moon, then a landing in one of the most difficult environments imaginable. Several critical mission milestones must be completed successfully because space is unforgiving. There are no emergency services, no rescue helicopters, no backup crews waiting nearby. When astronauts leave Earth, they take everything they need to survive with them. And if something critical fails, help is hundreds of thousands of kilometers away. History reminds us how fragile these missions can be. Apollo 13 was supposed to be routine. Then, an explosion turned it into a fight for survival. The crew made it home, but only because of extraordinary skill, preparation, and a little luck. Artemis III carries the same reality. Small errors during critical mission phases can have major consequences. One malfunction, one navigation error, one unexpected failure. That is all it takes. Yet despite all these dangers, humanity continues moving forward because Artemis III is about more than returning to the moon. It is a test of whether humans can live and work beyond Earth for long periods of time. A test of the technologies that may one day carry astronauts to Mars. A test of whether our species can truly become interplanetary. For the first time in over half a century, human footprints may once again appear on the lunar surface. But this mission is not a replay of Apollo. It is something far more ambitious, far more complex, and designed to test technologies that could one day carry humans deeper into the solar system. The moon is waiting, silent, frozen, unforgiving, and somewhere near its dark southern horizon lies a question. Humanity has never answered before. Can we survive there? Because Artemis III isn't just about returning to the moon. It's about discovering whether humanity is ready for what comes next.